These are the notes for Unit 6, Solving, Level 1. In order to solve, we have to go over what inverse operations are. Inverse operations are opposite operations that undo each other. So the inverse operation for add, addition, would be subtract. The inverse operation for multiply would be divide. Inverse operation for square would be square root. And then the inverse operation for cube would be cube root. You do this already whenever you solve for an equation. So let's do our examples here. X plus 3 equals 5. In order to solve for x, we need to isolate it. So that means if we have plus 3, addition, we need to do the inverse, would be subtraction. So we're going to subtract 3 from both sides, and we will have x equals 2. Multiplication. 2 times x equals 20. The inverse operation for multiply is divide. So I'm going to divide both sides by 2 so that I can isolate my x and solve for x. These 2's cancel and I get x equals 20 divided by 2, which is 10. So you've been doing this for a long time. You know how to do this, but you probably just forgot why you do it. So now this is a little bit trickier. You have x squared equals 36. The inverse operation for square is square root. So this means we're going to take the square root of x squared. What you do on one side of your equation, you do to the other side. The square root of x squared would be x, and the square root of 36 would be 6, or plus or minus 6. So if we have x to the cubed power, we're going to take the cubed root. So we're going to do a radical with a little 3 here of x3 equals the cubed root of 27. Remember, when we take the square root, you don't have to put a 2 here. It's understood to be 2. But if you have any number besides 2, you need to put that number there. So the cubed root of x cubed is the same thing as saying x times x times x. I have 3 x's, so I take 1 out. The cubed root would be x. So the same thing here, the cubed root of 27. If you have a calculator, you can do that. Or you could say that 27 is 3 times 3 times 3. I have 3 3's, so I can take out 1, and x equals positive 3. So this next section here, I want you to practice. I want you to match the inverse. So pause the video here for a few minutes and match the left side with the right side, the inverse of it. So if you've already done it, it should look something like this. X to the 4th, the inverse would be the 4th root of x. X squared goes with just the radical. We don't have a 2, but it's understood to be the square root of x. X to the 6th would go up here with the 6th root of x. And x to the 10th, we would have to take a 10th root of x to solve for x there. This is level 1. If you turn the page over, you have level 2. Unit 6, Solving, Level 2, Notes and Practice. So we're going to manipulate using a variety of methods: addition, subtraction, multiplication, division, divide, vector, and quadratic formula to solve for these equations. I'm only going to do 2, and then the rest of these are your practice problems for you to do. So example number 1. I have, in parentheses, 2x plus 2 squared minus 5 equals 11. I need to solve first. I need to isolate this, get it by itself. So the other thing that I have on the same side of the equation with that is the minus 5. Remember, the inverse of subtraction is addition. So I'm going to add 5 to both sides. And I have 2x plus 2 squared equals to 16. Now I have this whole thing, what's in the parentheses, squared. I need to get rid of the squared. Remember, the inverse of squared is square root. So I'm going to take the square root of both sides. 2x plus 2 squared equals the square root of 16. So I'm going to get 2x plus 2 equals a plus or minus 4. So now I need to solve. It can be either one of those. So I'm going to need to set up 2x plus 2 equals a positive 4. And then also I need to solve for 2x plus 2 equals a negative 4. To solve for x, first thing I have to do is get rid of my addition. I need to undo this, so I need to subtract 2 on both sides. And I get 2x equals 2. And then I divide both sides by 2. I kind of didn't leave myself enough room. And so I'm going to divide both sides by 2, and I have x equals 1. For the other situation, again, I'm going to subtract 2 from both sides. I'm going to get 2x equals negative 6, because negative 4 and negative 2 is negative 6. Divide both sides by 2, and x will equal to negative 3. So my solution set would be, let's just write it up here, a 1 and a negative 3. Now, absolute values. Do you remember solving for absolute values? We did that at the beginning of the year, and then we touched on it a little bit more later on in last semester. Again, just like with the squared, we need to solve and get my absolute value all by itself. So to do that, I'm going to subtract 2 from both sides, and I get the absolute value of 7 minus 3x equals 16. I need to have my matching pair of absolute value signs. Now remember that means that whatever's inside my absolute value, it can equal positive or negative. So let's just go ahead and put plus or minus 16 here. And then just like here, I have my two situations. I have 7 minus 3x equals a positive 16, or 7 minus 3x could also equal to a negative 16. I need to isolate for x, so the first thing I'm going to do is get rid of the 7. So if it doesn't have anything in front of it, it's understood to be positive. So 7 minus 7, those cancel. I get negative 3x, it's left on the left side. 16 minus 7 would be 9. Is that right? Yeah. Now I'm going to divide both sides by negative 3, and I get x equals a negative 3. So over here, I subtract both negatives from both sides, and I'm going to get negative 3x equals a negative 23. And I divide both sides by negative 3, because negative 3x means negative 3 times x. So the inverse of multiplication is division. You get x equals negative 23 divided by 3, that's not going to be even, but it is going to be positive. Negative divided by negative. 23 over 3. So my solution set for this one would be negative 3 and 23 over 3. So you have 6 practice problems to work on. Work on those. Check your answers with your teacher, wherever your teacher puts the answers, and good luck.